My name is SHAYA HABIB of BSc 3rd year 6th semester regular. My roll number is 225002. My university roll number is 221038401027. I am Maths Major 2 student. My subject is Advanced Algebra. I am here to give my presentation on the topic Finite Field. Finite fields are one of the essential building blocks of coding theory and cryptography, so they appear in many areas in IT security. Finite field. A field with finitely many elements is called finite field. We denote a finite field with q elements by f subscript q. Finite fields are also known as Galois field, named after Évariste Galois. Galois field. For any prime integer p and for any positive integer n, a field contains p to the power n elements is called Galois field. A Galois field is denoted by Gf p to the power n, where Gf stands for Galois field. For example, the ring Gf p to the power n is a finite field of characteristic p, where p is a prime number. Order of finite field. The number of elements of a finite field is called as the order of finite field. A finite field of order q exists if and only if p to the power k is equals to q, where p is a prime and k is a positive integer. Properties of finite field. Property number 1. The characteristic of a finite field is necessarily non-zero, but the converse is not true. Property number 2. Order of finite field of characteristic p is of form p to the power n, where p is prime and n is positive integer. An important note, for any finite field, number of elements must be prime or prime power. For any finite field, number of elements must be prime or prime power. For example, there exists no finite field with 6 elements, as 6 is neither prime nor a prime power. Property number 3. Every prime of finite field f with p to the power n elements satisfies the equation x p to the power n is equals to x. Property number 4. If a finite field f has p to the power n elements, then f is a splitting field of polynomial fx is equals to p to the power n minus x. Existence and uniqueness theorem. Here, in existence and uniqueness theorem, for every prime integer p and positive integer n, there exists a finite field with p to the power n elements, and this is unique apart from isomerism. Note: finite field having same number of elements are isomorphic. Theorem. Multiplicative group of a finite field is cyclic. Primitive element. If f be a finite field, a generator f star multiplicative group of a finite field is called primitive element. Note: multiplicative group of multiplicative group of a Galois field is also cyclic. Every finite field contains at least one primitive element. This means each finite field have at least one primitive element. Theorem. For each positive integer n, there exists an irreducible polynomial fx of degree n over ip, where ip is an integer, a group of integers which are prime. Theorem. If k is a subfield of Galois field gf p to the power n, then there exists an integer m such that k contains p to the power m elements, such that m divides n. Polynomial over finite field. A polynomial fx belongs to field kx is called an irreducible polynomial if it cannot be expressed as a product of polynomials of lower degree over a finite field k. That is, ux upon fx, either ux is equals to constant or ux is equals to fx. If a polynomial is not an irreducible polynomial, then it is called a reducible polynomial. Thank you.